Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to look at some more examples, a slightly complicated example that is related to implementing the idea of chain rule. Okay, so here we will start with question A. We have this function here, and you are asked to differentiate this function. Okay, right. We have fx. And fx here can be written as x squared plus x plus 1 negative 1 over 3. So the representation here can be changed to this one. And I'm going to consider viewing it as having an outer function and inner function, yeah, differentiating it with regards to outer function. So f prime x is going to be equal to, I'm going to first consider this outer function here. I'm just going to differentiate that first, and the result is going to be negative 1 over 3. Maintain whatever it is in the bracket here. So we have x squared plus x plus 1, negative 1 over 3 minus 1. So that is the result of differentiating the outer function. Okay, so next is I'm going to consider the inner function, which is this part here. Okay, so the result is going to be multiplied to the derivative of this function here, and it is equal to 2x plus 1 plus 0. So this one is a constant. The derivative is going to be 0. And based on this, we can simplify the whole process. This becomes negative 1 over 3 x squared plus x plus 1, negative 4 over 3, 2x plus 1, and this is negative 2x plus 1 over 3 x squared plus x plus 1, 4 over 3. Okay, so that is the answer to question A. Okay, all right, let's move on to question B. Let me just erase all ink on slide, and here we have this function gt. This is equal to t minus 2 over 2t plus 1. This is 9. Okay, so g prime t is going to be equal to, first we are going to consider the outer function, which is this one, and if you differentiate this becomes 9, and you're going to maintain whatever it is on the bracket inside the bracket here. So this is going to be t minus 2 over 2t plus 1 to the power of 8. So that's the result when you differentiate the outer function, and we're going to multiply the result here with this one. You have to differentiate this inner function here. So that becomes, if you want to differentiate that, we are going to have to apply the formula, which is, you can consider the top part here to be f prime, f, and the bottom part here is going to be g, and we're going to apply the formula, which is g f prime minus f g prime over g squared, in order to differentiate this part here. Okay, right. So now what is my g? G is 2t plus 1. Okay, 2t plus 1. And what is f prime? You differentiate this part, you will get equal to 1 minus f is t minus 2. Okay, and g prime is equal to 2. So g squared is 2t plus 1 squared. Okay. Next, we're just going to simplify whatever that we have here. So we have 9, and perhaps I can write down t minus 2 to the power of 8 over 2t plus 1 also to the power of 8. And here we have 2, I'm just going to take down the brackets here. So we have 2t plus 1 minus 2t plus 4 over 2t plus 1 squared. And that can be further simplified as 9t minus 2 to the power of 8, 2t plus 1 to the power of 8. And here on the top part here, this can be cancelled. So we have 5 over 2t plus 1 to the power of 2. And that can be simplified further with 45 t minus 2 to the power of 8, 2t plus 1 to the power of 10. Okay, so that is the final answer. Okay, all right. Now let's move on to the last example here. Okay, so here we have this function, which is equal to sine of cosine of tangent of x. Okay, and so in order to find the derivative of hx, again we are going to consider the outer function, the very outer function of this, which is this one. So what happens when you have sine? So what is the answer when you differentiate the sine of something? So the answer is going to be the answer is going to be cos. So if you differentiate a function which has sine on it, so the answer is going to be cos, and we're going to maintain whatever it is on the bracket. So it's going to be cos tangent of x. Yeah, so that's the answer. Next, we're going to consider differentiating the inner function. So inner function is this part. Okay, so if you differentiate cos of something, the answer is going to be negative sine of something. So we're just going to maintain this something here. So this is negative sine tangent x. Okay, and then finally, here we have the last part, which is this inner function. This is the very last function here, tangent of x. So if you differentiate tangent of x, the answer is going to be secant of x squared. Yeah, so based on this, we can try to perhaps write it down in a simplified manner, but I don't think there is much that can be simplified. But let us try to do this. Perhaps the negative sign can be brought forward. So here we have negative cos of tangent of x, and then we multiply with sine tangent of x. Okay, and then we have secant of x squared, and I think that is all that we can do. Yeah, all right, that's all for now. Thank you very much for watching.